Dear students, this is Dr. Pradeep Devhate, Associate Professor, Department of Chemistry, Sri RLT College of Science, Akola. In this video lecture, I am going to talk on reactions of aldehydes and ketones, especially the name reactions. Let's discuss the reaction of aldehydes and ketones one by one. First, Ketones-04 reaction. Aliphatic or aromatic aldehydes do not containing alpha hydrogen. Aliphatic or aromatic aldehydes do not containing alpha hydrogen. When heated with concentrated alkali, it undergo a disproportional reaction. One half of the aldehyde are oxidized to alkali metal salt of carboxylic acid and other half are reduced to an alcohol. One half of the aldehydes are oxidized to alkali metal salt of carboxylic acid and other half are reduced to an alcohol. This reaction is given by Italian chemist Stanislao Cannizzaro in 1853, and hence it is specially known as Cannizzaro reaction. Formaldehyde and benzaldehyde do not containing alpha hydrogen gives this reaction. The first example of Cannizzaro reaction is reaction of formaldehyde with 50% NaOH solution. When formaldehyde heated with 50% NaOH solution, one molecule of formaldehyde is oxidized to sodium formate, whereas its other molecule is reduced to methyl alcohol. It means half of the molecule undergoes oxidation, whereas other half undergoes reduction. Here, initially NaOH get dissociate to form Na positive and OH negative ions. The nucleophile OH negative attack on first molecule of formaldehyde, and the anion obtained is reacts with second one to form sodium formate and methanol. Next example is reaction of benzaldehyde with 50% NaOH solution. When benzaldehyde is heated with 50% NaOH solution, one molecule is oxidized to sodium benzoate, whereas other molecule is reduced to benzyl alcohol. In this way, benzaldehyde gets converted to sodium benzoate and benzyl alcohol. Here, benzaldehyde gets converted to sodium benzoate and benzyl alcohol. Next is cross Cannizzaro reaction. The reaction in which two different aldehydes do not containing alpha hydrogen are heated with concentrated alkali is called as cross Cannizzaro reaction. The reaction in which two different aldehydes not having alpha hydrogens are heated with concentrated alkali is the cross Cannizzaro reaction. Here also, one of the aldehyde get oxidized to alkali metal salt of carboxylic acid and other get reduced to alcohol. Example of cross Cannizzaro reaction is reaction of mixture of formaldehyde and benzaldehyde with 50% NaOH. When formaldehyde and benzaldehyde are heated with 50% NaOH solution, that is sodium hydroxide solution, formaldehyde is oxidized to sodium formate, whereas benzaldehyde is reduced to benzyl alcohol. Here formaldehyde gets oxidized to sodium formate, whereas benzaldehyde is reduced to benzyl alcohol. Please keep in mind, here never there is a formation of sodium benzoate and methyl alcohol. Here always the formation of sodium formate and benzyl alcohol. Next to this is Reformatsky reaction. Reformatsky reaction. Aliphatic or aromatic aldehydes and ketones. Aliphatic or aromatic aldehydes and ketones, when reacts with alpha bromoester and zinc metal in presence of diether, gives beta hydroxyesters. Aliphatic or aromatic aldehydes and ketones reacts with alpha bromoester and zinc metal in presence of dry ether, gives beta hydroxyester. This reaction is known as Reformatsky reaction. Example of this reaction is reaction of acetaldehyde with alpha bromo ethyl acetate and zinc metal. Reaction of acetaldehyde with alpha bromo ethyl acetate and zinc metal. When acetaldehyde is treated with alpha bromoester and zinc metal in presence of dry ether, beta hydroxyester is obtained. Here beta hydroxyester is obtained. Here initially acetaldehyde, alpha bromo ethyl acetate and zinc metal reacts with each other in presence of dry ether to give organo-zinc compound. Formation of organo-zinc compound by the reaction of acetaldehyde, alpha bromo ethyl acetate and zinc metal. This organo-zinc compound is then hydrolyzed to give beta hydroxy ethyl benzoate, beta hydroxy ethyl benzoate, which is nothing but the beta hydroxy ester. Next example is reaction of benzaldehyde with alpha bromo ethyl acetate and zinc metal. This is the reaction of benzaldehyde with alpha bromo ethyl acetate and zinc metal. Just like the previous reaction, here also the similar reaction takes place. Initially benzaldehyde get converted to organo-zinc compound by its reaction with alpha bromo ethyl acetate and zinc metal. Then this organo-zinc compound get hydrolyzed by acid to yield beta hydroxy beta phenyl ethyl propanoate, beta hydroxy beta phenyl ethyl propanoate, which is again beta hydroxy ester. This is the example related to the reaction of benzaldehyde with alpha bromo ethyl acetate and zinc metal. This is the Reformatsky reaction. This is the example of Reformatsky reaction. Next example are of ketones. First one is reaction of acetone with alpha bromo ethyl acetate and zinc metal. Reaction of acetone. When acetone is treated with alpha bromo ethyl acetate and zinc metal Of course, in presence of dry ether, here beta hydroxy beta methyl ethyl benzoate is obtained. When acetone is treated with alpha bromo ethyl acetate and zinc metal in presence of dry ether, alpha hydroxy beta sorry beta hydroxy beta methyl ethyl benzoate is obtained. During the reaction, there is formation of organozinc compound, which is then hydrolyzed. Last example is the reaction of acetophenone with alpha bromo ethyl acetate and zinc metal. Reaction of acetophenone, Reformatsky reaction. Here the product is beta hydroxy beta phenyl ethyl butanoate. Beta hydroxy beta phenyl ethyl butanoate. Here also the same reaction takes place just like the previous reactions. Here also the product is 3-hydroxy. The product is beta hydroxy ester. All these beta hydroxy esters on further acid hydrolysis followed by the heating get converted into alpha beta unsaturated acid. These beta hydroxy esters on further acid hydrolysis followed by the heating always get converted into alpha beta unsaturated acids. Next name reaction is Perkin reaction. Perkin reaction. Aromatic aldehydes, when heated with anhydride of aliphatic acid containing at least 2 alpha hydrogens and sodium salt of same acid which act as catalyst, condensation takes place to form alpha beta unsaturated acids. Aromatic aldehydes, when heated with anhydride of aliphatic acid having at least 2 alpha hydrogens and sodium salt of same acid, condensation takes place to form alpha beta unsaturated acids. Here, essential condition is that aldehydes should contain at least 2 alpha hydrogens. This reaction is given by Perkin in 1868 and hence it is known as Perkin's reaction. Example of Perkin reaction is reaction of benzaldehyde with acetic anhydride and sodium acetate. When benzaldehyde is heated with acetic anhydride and sodium acetate at 180 degrees centigrade for about 5 hours, cinnamic acid is obtained. Here during the reaction there is a loss of simple molecule of acetic acid. Here benzaldehyde and acetic anhydride reacts with each other in presence of a strong base sodium acetate and alpha beta unsaturated acid, that is cinnamic acid is obtained. Let's see the mechanism of this Perkin's reaction. It involves overall 4 steps. First step is formation of acetate ion and carbanion A. Formation of acetate ion and carbanion A. Here Sodium acetate dissociates to give acetate ion. It abstracts alpha hydrogen from acetic anhydride and forms the carbon ion A. See the reactions. Sodium acetate get dissociates into CH3COO negative, that is acetate ion, and Na positive. This acetate ion CH3COO negative then abstracts alpha hydrogen from acetic anhydride to get the carbon ion A. Here there is a formation of carbon ion A. During this, there is a removal of acetic acid. This is the first step, that is the formation of acetate ion and carbon ion A. Second step is attack of carbon ion A on carbonyl carbon of benzaldehyde to give anion B. Attack of carbon ion A on carbonyl carbon of benzaldehyde to give anion B. In this step, carbon ion A, which is formed earlier, attacks on carbonyl carbon of benzaldehyde and produce next intermediate stable anion. Next intermediate stable anion B. This is the second step. In the third step, anion B get protonated by the acetic acid, which is formed in first step, to give intermediate, that is intermediate C. In this step, anion B get protonated by the acetic acid formed in step 1 to give intermediate C. This intermediate C loses water molecule and form the alpha beta unsaturated mixed anhydride, that is anhydride D. See the reaction. Initially, formation of intermediate C by the protonation of anion B using acetic acid. Formation of intermediate C by the protonation of anion B using acetic acid, and then loss of water molecule to form the alpha beta unsaturated mixed anhydride D. Alpha beta unsaturated mixed anhydride D. This is the third step. The last step, that is the fourth one, is hydrolysis of alpha beta unsaturated mixed anhydride D to give the cinnamic acid. Hydrolysis of alpha beta unsaturated mixed anhydride D to give the cinnamic acid. Here, anhydride D get hydrolyzed to form the final product cinnamic acid with loss of acetic acid. This is the complete mechanism for conversion of benzaldehyde to cinnamic acid. This is the mechanism of Perkins reactions. Student friends, for next name reactions of aldehydes and ketones, please do watch my next video lecture. Have a good day. Thank you.